Today we will learn about the next point of the chapter current electricity, in that meter bridge. Meter bridge consists a uniform cross section wire with a length of 1 meter. This is the uniform cross section wire with a meter scale, and that meter scale is started from the 0 centimeter to total 100 centimeter is length. That means we can say that there is a total distance of that wire, cross section wire, having a length 1 meter. There is two L-shaped strips which are fixed on the wooden table. These are the two L-shaped strips. A single strips wire is fixed between these two L-shaped strips. That single strips having a point C. A single strips is kept in such way that there is a two gap. One is the left gap and another is the right gap. In the left gap there is always a known resistance, and in the right gap there is always known resistance. Again, the EMF of cell, key and rheostat are connected along the wire between the uniform wire, that A and B. From point C, the one point is connected to galvanometer, and galvanometer is connected to jockey, which get a point on the uniform wire. That point is D, where we get a null deflection in the galvanometer. At that time we say that there is a balance condition is verified, or the Wheatstone bridge condition is applied. At that time, this at the galvanometer there is a null deflection or null point on the uniform cross section wire. That wire is AB, and in that condition we can say that we know that the Wheatstone bridge condition, in that P upon Q is equal to S upon R. This is the Wheatstone bridge condition. That means balance condition. When that balance condition is comes when the null deflection in the galvanometer. इथं galvanometer मध्ये जर null deflection असेल, so from that we can say that this X is unknown resistance, this R is the resistance box from the known resistance box, and this length which is along the unknown resistance, that length is called as Lx, and the length along the known resistance, that is Lr. And from that we can say that using that Wheatstone bridge, that we should write here X upon AD is equal to R, X upon R is equal to AD upon DB. What we should write here? We should write here the Wheatstone bridge condition, in that XR is equal to AD upon DB. That means resistance of AD and resistance of DB. This resistance, in 11th standard we learn that resistance at any point is equal to, on the wire, is specific resistance, that is rho, and length of that wire is suppose L, and area of cross section, this is the resistance of this wire. If we can apply this formula here, that means the resistance of that wire AD, in that we write here RAD is equal to rho, that is specific resistance of that wire which is uniform at anywhere, and again length of that wire is Lx and area of cross section, that is A. Again we can find out resistance at the dB, that means we should write here rho LR upon area of cross section, that is A. When we can substitute these values here, then we write here, that is x upon R is equal to RAD. Instead of that, what we should write here, rho Lx upon A, and this term is divided here, and so this numerator goes to denominator, denominator goes to numerator and numerator goes to denominator. So we should write here, that is A upon rho LR, and those terms are common, they are cancelled here, and we write here, that is x by R is equal to Lx upon LR, and from this we can find out the unknown resistance, that x is equal to R Lx upon LR, and this equation is called as a known resistance of that wire, unknown resistance of that wire, that x is equal to R Lx upon LR. But here we can see about the error of this meter bridge. In that, error is nothing but in that the cross section wire may not be uniform. This is the first error. Which is the first error? The wire which is used, it may not be uniform. Again, second error, in that in here, if we can consider the wire between this AB, this uniform wire is in contact of that metal strips, and there is a contact resistance, there is developed a contact resistance, and we can say that this contact resistance is not measured in account, that is contact resistance is developed. This is the second error. And third error, the value of Lx and Lr may not be measured accurately. These are the three errors. Again, how to minimize this error? This error is minimized in that we use, to minimize the error, for that we should use here that uniform wire, and again the value of take the value from the known resistance in such way that the null point is obtained between the 34 centimeter to 66 centimeter. This is the minimize the error which comes in the meter bridge. And second, repeat the experiment interchanging the position of unknown resistance and the known resistance. This is the second error. And third error, in that the wires or that jockey is tap on that cross section wire and not slide on that wire. This is the third minimize. Using this third point, we can minimize the error of that meter bridge. Again, uses of this meter bridge, in that we can measure the unknown, very low unknown resistance preciously. And second uses of this meter bridge, in that we can also measure the resistance of resistance of the galvanometer and impedance, capacitance and inductance are also measured by using Wheatstone meter bridge. Thank you.